Okay, the function is defined on closed interval -5 to 4. And the graph of the f consists of 3 line segments, and is shown as figure above. Yeah, there's 3 line segments. Okay, all right. Figure above. That's to the right, buddy. Settle down. Let g be the function defined by the integral. Oh, that's interesting. Okay, all right. So g is the integral of f from -3 to whatever x value you decide. That's interesting because the integral of f is the area beneath f. The integral of f is the area beneath f. So, since g is the integral of f, then g calculates the area of underneath f, or the area on the net area underneath the curve of f. So that's something to keep in mind. Find g of 3. Okay, that means you plug in 3 there and 3 there because that's where the x is. And so you're finding the area from -3 till 3, right? Okay, that's easy. This is a triangle. You just find the area. That's 3 by 4, 1/2 times base times height. That's 6. 2 and 4, right? 1, 2, 3, 4. 2 and 4, that would be just area of 4. And then this area, the area here, looks like it cuts off there, that would be -1, right? Because it's negative and is 1/2 times the base. Base is 1, height is 2. And so there we go. So the area, the net area, for under the curve from -3 to 3 is 9. Is 9. So this is 9. It's very simple. This is 9. This answer is worth 1 point. You just have to interpret that it's the area, and you get 1 point for answering it correctly, and it's 9. So, on the open interval contained in -5 to 4, is the graph of g both increasing and concave down? Oh? Give a reason for your answer. All right, so this takes some thinking. They're asking about g. They're asking about g. So we can't really think of, well, maybe we can. On the open interval from -5 to 4. -5 to 4. Is the graph of g both increasing and concave down? Okay, so the graph of g. G, if we had the graph of g, to find out if it was increasing or decreasing, we'd have to look at the slope of g. But the slope of g is the derivative. By the fundamental theorem of calculus, we know that if we took the derivative of g, we would get f if we just plug in that x. Hopefully you remember that. But so then this you could say, so this is part B. By the fundamental theorem of calculus, g prime of x equals f of x. So, if we want to think about whether g is increasing or decreasing, all we have to do is look at f of x, which is given by our graph here. So, if we're looking at g prime, which is f of x, we have to see when f of x is positive, because that means the derivative of g is positive. So f of x is positive from -5 to 2. So f of x is positive from -5 to 2. That means g of x is increasing from -5 to 2. Undo. And then it's also decreasing because it's the f is negative, so g is decreasing from 2 to 4. So g is decreasing from 2 to 4. something to be careful about is saying G instead of it. Don't say it is decreasing, because then the reader doesn't know what you're talking about. So make sure you're specific with your pronouns. Now to think about concavity, you just think of the derivative of F, right? Because that would be the second derivative of G. So here we'll just take the derivative of F. And so we have the derivative is negative, so that means G is concave down. Derivative is positive, positive slope. G is concave up, and then concave down for those intervals. And then the other parts would be concavity. So, I paused it in between. I don't know if I said that already. To get the concavity, we think about this. Oh, wait, I did say that. So, where would it be concave up? It would be concave up where G double prime is positive, which means where the slope is positive. So it would be concave up here. So it would be increasing, no, I mean concave up when between, and now when I say it, I mean G. G is concave up between -3 and 0, and that's it. Between -3 and 0. And it's concave down for the rest. So what was the question asking? I was just saying stuff. On what open intervals between -5 and 4, so on what open intervals from there to there, is the graph of G both increasing and concave down. So the intervals where it's increasing and concave down. So I explained some stuff. It's increasing from, so G is increasing from -5 to 2, and it's saying concave down. Concave down for anything but -3 and 0. So where do they overlap? From -5 to 2, -5 to +2, G is increasing. And then from concave down, what is -3 to 0 is concave up. So concave down would be negative, well, I'll do it in a different color, green. -5 to -3, and then 0 to 4. So they overlap. Well, I guess, yeah, they overlap there and there. So what are those intervals? So G of X is increasing and concave down on -5 to -3, -5 to -3, and 0 to 2, and 0 to 2. So in this problem you get 1 point for your answer, and then 1 point for all the reasoning that you said. So they would grade this as a point. So that's part B. What is part C? Let me erase stuff. All right, part C says the function h is defined by the quotient g of x divided by 5x. Find h prime of 3. So we have to take the derivative of this. This is testing to see if you know the product rule. So h prime of x, that'll be just the product rule. So that's low d high minus high d low all over low squared. And then just know that g prime of x is f of x. And then g of x is the area under f of x, or the net area under f of x. Actually, it's f of t. So then I'm calculating that when I plug in 3, right? So I'm just plugging in 3. So h prime of 3 would be 5 times 3, that's there. And then g prime of 3, that's the same thing as f of 3. So f of 3 would be 1, 2, 3, and then negative 2, I think. So times negative 2 minus g. G is the net area, so g of 3, it would be the net area from negative 3 till positive 3. Did we already find that? We did. That was 9. Sweet. So that would be minus 9 times 5, all divided by 5 times 3 is 15 squared. Plug that in, I think you get negative 1/3. So on this part, you get 2 points for writing down h prime properly. So it'd be that stuff in black. And then 1 point for the answer. So 2 points for this, 1 point for the answer. And there you go. That was C. Now what's D? The function P is defined by f of x squared minus x. Find the slope of the line tangent to the graph of P. I'm going to do this in another video because it's already taking a long time.